Assalamualaikum sir, my name is MD Mubarak Hussain. My ID is 235442773 and today I will be presenting my OBE assignment for the course Digital Logic Circuit. This project is about designing and digital parking control system. Now moving on to the next slide. Table of contents. System overview, block and flow diagram, timer circuit design, FSM and Verilog limitation and improvements, and last is conclusion. Now moving on to the next topic, system overview. The goal of the project is to build a smart system for managing parking in a garage with a fixed capacity of 12 cars based on my ID. It should full when the garage is full and blinking space available when there is still room. This is done using sensor, counter, display and logic circuit. And now moving on to the next slide. Block and flow diagram. The system starts with sensors at the entry and exit gates. This sends signals to a 4-bit up-down counter based on my ID. The counter keeps track of how many cars are inside. A comparator checks if the count equals 12. Based on that, the system activates either the full or space available display using logic control. Now moving on to the next slide. The next slide is timer circuit design. 255 timers are used in the design. The first one keeps the full display control on. The second one control a blinking of the space available manage. Based on my ID digits, I calculate a duty cycle of 66% and a frequency of 8 Hz. I select a 250 microfarad capacitor with resistor values of 231 ohm and 245 ohm to achieve the desired output. Now moving on to the next slide. This next slide is FSM design and Verilog. To manage timing, I design an FSM that output A for 4 millisecond and B for 4 millisecond. Since T high and T low are limited to 4 by the question, I use a 3-bit FSM with 8 states switching from A0 to A3 and B0 to B3. I also wrote Verilog code that generate the correct output based on these states. Now moving on to the next slide is limitation and modification. The system works but has some limitation. It can only handle 12 cars and doesn't show the exact count. It also depends completely on sensor and the 555 timers lacks control input. To improve it, we could use a 5 or 6-bit counter, add a 7-segment display, or use a microcontroller like Arduino for flexible digital control. Now moving on to the next slide. Conclusion. In conclusion, I successfully built a digital system that manages parking logic using counters, timers, FSM, and displays. It shows how digital logic applies to real world problem, and with a few improvements, this system can be scalable and more intelligent. Thank you, sir. Thank you, everyone. Assalamualaikum.